have a look at this photo. This photo is the aftermath photo of Gulf of Mexico oil spill happened in 2010. Okay, you can see that the oil spill expand towards several hundred kilometers of the Gulf of Mexico water, and they have to contain a million tons of oil that spill on the ocean just to save the environment. Okay, in this photo, which one is the analyte, sample, and what are the matrices? Okay, it depends on the sample that you collect. In this case, straightforward, the sample is water. Water as your sample. Okay, where's my pen? Okay, water as your sample. Seawater, Okay, your analyte is what's inside the oil. Okay, so seawater can contain both water and oil. If let's say you happen to sample here, means that the sample contains seawater and oil. So the analyte is most of it is hydrocarbons, because hydrocarbons are those that makes up the oil. Okay, and then what are the matrices? Means that is everything inside this seawater as well as oil. Okay, let us look at the several other examples. Okay, type of sample and matrix can be anything. It depends on the analyte that we are going to analyze. Once again, analyte is the chemical compound or chemical compounds that you want to analyze. Okay, the sample is the oil sample from the Gulf of Mexico oil spill disaster, and the analyte can be anything from hydrocarbons, methane, pentane, hexane, everything, to sulfur or even trace metals. Okay, it's up to you what you want to analyze. If you are asked to analyze hydrocarbons, then hydrocarbons is your analyte, while sulfur and trace metals are your matrices. Okay, remember matrix is the any other constituent inside the sample except your analyte. Okay, in this case, in this photo, water as your sample, soil or sand that contain the oil can also be your sample. Okay, in this next one is smoke as your sample. If it's combusted on the ocean, you collect the smoke. Smoke is your sample. So what's inside the smoke that you want to analyze? Do you want to analyze H2S? Do you want to analyze nitrous oxide? Do you want to analyze carbon monoxide? That's your analyte. Okay, and also your sample can be even anything else that is been contaminated with the oil from the disaster. Okay, all of these are your sample, and analyte depend on your objective of analysis. Okay, now I'll show you another examples. Okay, in this case, this is pollution and pollution. Okay, you are given the task to analyze, to determine what killed this fish. Okay, the question is what killed the fish. So this is qualitative. Okay, because we only want to know what. Is it important for us to determine the quantity? Yes, it may, but whatever is inside it, whether it's low concentration, high concentration, it already killed fish. So the major question is qualitative. Okay, so in this case, the sample is your fish. Fish is a solid sample, and you want to determine what's inside. What's inside is your analyte. Do you know what is the analyte? Of course, no. That's why we want to know the chemical compound. Okay, that's the case on pollution. What if you have the case of routine monitoring of pesticide inside apple? Okay, pesticide inside apple. Okay, why pesticide is in apple in the first place? Because it's been sprayed with pesticide or herbicide during its plantation. Okay, you want to know that. Okay, Is it relevant to go into quantitative? Yes, because we want to know how much is it inside the apple, and if we eat it, it will harm our body system. So we want to know on quantitative. Okay, the same thing in soil. Okay, how much of the parathion is the insecticide, how much inside it, or you can even analyze how much is the NPK, nitrogen, phosphorus, potassium, usually inside fertilizer. Okay, so the type of sample can be anything. It depends on the thing that we are going to analyze. It depends on the analyte. Up until now, of course, you will be confused. If I have this kind of sample, having this kind of analyte and this kind of matrix, which one I should choose? Okay, don't worry. I will give you the differentiation as well as the similarity for you to understand the classification. Okay, now go back to the steps in quantitative chemical analysis. If you remember as well as memorize this and understand it, of course, your chemical analysis is at least 50% successful already, because you understand what you are doing. Okay, I will talk about the first three. Okay, the first three elements in quantitative chemical analysis. The first one is to understand and define the problem. Okay, if you know the sample, if you know the analyte, and if you know your objective of the analysis, you already understand the problem already. Problem solved. Okay, after you understand the problem, okay, now the second question, how do we want to analyze these chemical compounds in this kind of sample? Where should I find this information from? So that's what we call as literature search. Literature means references. Okay, the first step is you have to go to standard method first. So what is standard method? I will explain later. Basically, in forensic chemistry, you have to go to standard method first. If you don't have standard method, then you can go towards published methods. What are published methods? Methods that are published by researchers all over the world, that has been validated. Okay, and some of them have been widely accepted, okay, around the world, but it's not been standardized into a certain regulation. Okay, but it is commonly used. That's what we call as published method. And then after you do literature search, okay, I know the method already, I know what should be done, I know what shouldn't be done, then you select the best analytical method. Okay, the word I miss putting here is the select the best analytical method. Okay, sometimes for a given sample and analyte, you will have 2 or 3 or 4 method that is suitable, but which one is the best? The best means that which one will give you the shortest chemical analysis time, which one will give you the cheapest analytical cost, and which one will give you result that is really accurate. That's what we call as the best. Okay, after that, okay, you know already which one to select. Then you go out. Okay, for example, if you have a crime scene, then you ask the CSI team member to sample for you. Okay, forensic analytical chemist doesn't usually go to CSI. You will learn about it in CSI later. Doesn't usually go to sampling, but you can do it if sampling in the first place is not satisfied by the CSI team member. Okay, but usually it's not like that. Okay, you sample and you preserve. Why preserve? Because we want to analyze the sample and analyte same like what we collect on the site. And then of course storage. What kind of storage I should I should do. You will learn a lot in CSI subject, not in this subject, okay? And then, after that, go back to the lab. Then you have the sample preparation. You have like millions of sample preparation steps, and which one to choose, okay? After you sample prep, okay, now the sample is clean, you can do analysis. The analysis will be done mostly using instrument. This instrument you will learn with Dr. Afiq, okay, or Dr. Hasmiria on forensic analytical instrumentation. You will learn about instrumentation, okay. So I will not cover in this subject. The analysis will usually take around 10 minutes to 20 minutes only, but sample preparation will make you headache for several days or even weeks, because you want to have a very clean sample and analyte goes into instrument. After you get data, you will apply statistic, which will be covered by Dr. Naji at the end of this subject to verify your results, okay. Without statistic, it's hard to believe your result. And then you report and go to court. Okay. Then, the question is how long every steps in this chemical analysis takes up to. Usually it's months. Okay, because we validate the data. Once we get the data, we verify data, validate again, verify, just to make sure that it's accurate. Okay, accurate means that we are going to do the correct decision in court.